Welcome back. We are going to focus on Module 20, and we will be dealing once again with confidence intervals, but now we're not going to be just dealing with a straight 95%. We're going to explore higher and lower confidence interval levels. First, we want to know which one of these questions asks us to test a claim about a population proportion. Now, testing a claim is where we're determining, like, is this percent less than last year? Is this percent the same or different than last year? Those are some different ways that you could perform a test. Now, this question says, what proportion? The second question says, do more than. And the last question says, average course load, okay, and greater than. Those are the things that stand out to me. What proportion is asking us to estimate a proportion? They're trying to create a confidence interval here to actually capture P. A bond measure takes 2/3 majority to pass, do more than 67%. So first of all, it's testing a claim and it's using a percentage. So we have a percentage and we're testing a claim. This is our answer. Number 3 says average course load. We're testing a claim here by asking greater than, but this is average, which is not a percent, that's mean, and we will focus on that later. Okay, let's answer some questions on the learn by doing. Foothill College's athletic department wants to calculate the proportion of students who have attended a women's basketball game at the college. They use student email addresses and choose 220 students and email them. 145 responded and 22 had attended a basketball game. Now, 220 was what they wanted the sample size to be, but due to non-response bias, we only have 145. That means that our N is 145. Don't be fooled by the two numbers. The sample proportion then, P hat, is equal to 22 out of 145 or 0.152. Show calculations to confirm that the sampling distribution of the sample proportions will be a normal distribution. Well, if you notice in this question, we are not given the population proportion, which is most likely what's going to happen. Now, since we don't know that, we can't do NP and N1 minus P greater than or equal to 10. We can't check that normal condition. However, we can use P hat as an estimate and calculate based on that. So then we'll take our sample size of 145 times 22 over 145, which is 22, and that is greater than 10. And then we'll take 145 times 1 minus 22 over 145, which is equal to 123. That is also greater than or equal to 10, so the normal condition has been met. Now we want to find a 95% confidence interval. Remember, when we wanted to calculate the standard distribution of the sampling, standard deviation of the sampling distribution, we used P times 1 minus P over N. Again, we don't have P, so we're going to use P hat as our estimate. That means that we have the square root of 0.152 times 1 minus 0.152 divided by 145, and we get 0.03. Remember that our confidence interval is a P hat times the margin of error, or P hat plus or minus 2 times the standard error. We're going to take 0.152 plus or minus 2 times 0.03 and get the interval 0.092 to 0.212. So we're confident 95% of the time our interval of 9.2 to 21.2% will capture the true proportion of people who have attended the women's basketball game. Now, what's our margin of error? Well, remember that our margin of error is after the plus or minus. That's going to be 2 times 0.03, which is 0.06. Okay, well, what if we change to a 90% confidence interval estimate instead of 95? Well, we know from the standard Z distribution, the 68, 95, 99.7% rule, that 68% fall within 1 standard deviation, 95 fall within 2, and 99.7 fall within 3. Well, we have to figure out what endpoints will have z-scores in what interval. What's the z-score going to be? We knew that the z-score for this was about 2, but what's 90%? So if you looked in OLI and you actually went through the work, the z-score will have an interval, or the z-score will be plus or minus 1.65. And a lot of times online, you'll see 1.645 is just a little bit more accurate. Using StatCrunch, find this 90% confidence interval estimate and then calculate the margin of error. We're going to hop over to StatCrunch now and calculate. Okay, first you want to click Stat. Then you're going to do proportion stats for one sample, and we're creating with summary. With data means you have a list of all of the different sample values. Most times you're going to just do with summary. We had 22 successes in this problem, and we had 145 observations. And then you have to jump down and switch to confidence interval. And we're calculating 90% now, so we're going to change this to 90. So we've put in 22 successes, 144 observations, changed it to confidence interval for 0.9, and you can leave the method alone. Computing, we see that the standard error is 0.02979, which rounds to 0.03 or 300ths. The lower limit was 0.102, and the upper limit was 0.201. I'm also going to calculate 98% since we're here. What we can do is go to Stat, Proportion Stats, one sample with summary. Our number of successes is still 22 with 145 observations, but now we're changing our confidence level to 0.98 and computing. Our confidence interval now is 0.08 to 0.221, and we're going to use this information to calculate the margin of error.